Thank you very much, Meredith, for this introduction and for putting together this very nice conference. So I'm going to tell you a little bit of the work we've been doing last year together with this great group of collaborators, especially Badr Barami played a very big role in putting this project together. And I want to start off with a story around Brexit, where David Cameron, according to his recent book, he signaled that Boris Johnson actually was not a very firm believer in Brexit itself. So according to Cameron, Johnson said to him that that Johnson risked an outcome he didn't believe in himself because it would help his political career. And on this account, Johnson actually was pretty certain that the Brexit side would lose. So backing that side actually brought little risk of breaking up the government. He wanted to lead one day. So it would be a risk-free bet on himself. And I think you see here a beautiful example of a strategic behavior of a politician trying to actually, get attention drawn towards, in this case, himself. And by being strategically different or actually misaligned from the ruling government. I think such competition for social influence, I think, is a major force that shapes our societies, being it politicians competing for voters, being it financial advisors competing with each other for clients, but also on internet where social influencers, of course, compete against each other for attracting attention, from getting likes and followers. Today I want to talk a little bit about the strategies that maximize social influence in these kind of situations. And of course, I'm shaping here different types of situations. And I want to cover three different aspects today. First, I want to talk a little bit about what are actually the hallmarks, what are the characteristics of these scenarios where competition for social influence takes place. Then, using these characteristics, I'm going to apply game theory to derive the rational strategy. So what is a rational agent expected to do? And after deriving this rational strategy, I will put it to the test empirically, see if it can actually sway human clients or not. So we argue here that hallmarks of competition for social influence have three key characteristics. That is not to say that each situation you will encounter will have always the same ingredients, and they may vary in their strength. But I think many situations, including the Brexit example I just gave, this is one of the important features. And the first one is an information asymmetry. And whereby influence seekers, for example, politicians or financial advisors, they actually know more about, or at least they're expected to know more about an issue than the people that they seek to influence. And that this gives, of course, room for strategic behavior. I think was, for example, also shown by this big red bus that you might remember, where during the Brexit campaign there was this big bus driving around Britain, making a claim that London was pouring a lot of money into the EU, and that they could do much better by actually moving forward with Brexit. Turned out this claim was wrong, but the damage had been done, and the damage can be done because we to some extent trust politicians to tell us the truth that we find difficult to actually gather because the issues are so complex. A second key element that you often see here is that that clients hand over power to their advisors to make decisions on their behalf. So we elect politicians to make decisions for us. We decide on which financial advisor to take, who makes financial investments on our behalf. So we give the power to make a decision away. And thirdly is uncertainty. And of course, uncertainty is a big term, can happen on many levels. What I mean here is the future uncertainty. So that is actually difficult to predict the outcome of an event. And of course, if an event is difficult to predict, that again gives you more leeway for using strategic behavior that actually deviates from the evidence, because you can always claim that, well, but it was uncertain, I didn't mean like that. So the fact that the future is hard to predict actually gives, we think, also a lot of wiggle room for strategic behavior. Now, having identified these key elements, I'm gonna use kind of very simple lab-based kind of paradigm on social influence to derive the rational strategy, having these key elements really at the forefront. And this is work that is largely done by Jurgen Karpus, who's a postdoc with Badr Barami, and also in collaboration with Badr and with Ken Birmore. But I'm going to walk you through this. So the situation we're discussing here is a very basic one, where there's one client and there are two advisors, and these two advisors are competing for the attention of that one client. So there are only three players in this game, and here are three players again. And the client is basically trying to maximize his winnings in a lottery. So it has to decide, is the lottery outcome going to be white or black? But the client itself has no information about, has actually no evidence about what the state of the world is. But the two advisors have. So here you see this information asymmetry, with advisors actually having access to evidence and not the client. And what we're going to focus on here, what we're really asking is, given the certain state of the world, so and this is actually the probability that the outcome is going to be black, which in this scenario is 0.75. How should the advisor actually communicate that evidence to a client with the aim of maximizing its social influence? And with maximize social influence, I mean that is being selected or chosen as often as possible. So the advisors basically, they basically want to be selected by the client on as many rounds as possible. Now, the strategies that advisors can choose from, we fix them between 0 and 1 in incremental steps of 1/9, with 0 being I'm very, very confident it's going to be white. So if an advisor selects strategy 0, it basically communicates to the client, okay, I'm absolutely certain it's going to be white. And at the other extreme, it can choose black. It can choose 1, which will be extremely high confidence for black. So the 0 and 1s are the very extreme strategies. And for example, a 4/9 would be still, I believe it's going to be white, but I have very low confidence in this. So this is, you can see it as a confidence scale. And looking at the different strategies that you can at least verbally think of that you can now choose as an advisor in this game, you can, for example, think, okay, I can choose an honest strategy. I'm just going to communicate exactly the available evidence that I see to the client. You can also say, maybe it's actually better to be moderate. I just gonna try to actually, make no big errors. Or you could say, well, I'm gonna go extreme. No matter what evidence, I'm always gonna, provide an extreme evidence, just to give you a flavor of the different strategies that could emerge in the end as the rational strategy. Now, the client follows always the advice of the selected advisor. So again, this is this delegation of the decision. So if the client selected an advisor and that advisor would have provided the advice of 0 till 4/9, it means, okay, I believe it's going to be white. So then the client actually bets on a white color. And same over with any advice 5/9 or higher, which would mean, okay, the selected advisor tells me it's going to be black, so I will bet on black. Okay, so that's from the perspective of the advisors. These are the advisor strategies. What does the client do? What's the client strategy? Specifically, how does the client select which advisor to take on each round? And what the client does is it basically keeps track of the weight that it gives to each of the two advisors, and that weight sums to 1. And the client selects the advisor with the highest weight, which is pretty straightforward, right? So if you give more weight to one advisor, you select it. The crucial piece here is, of course, the updating rule. How do you actually update these weights? And the client used the following formula that, I don't want to go into detail here, but what is important here is that this weight updating rewards high confidence correct choices and it penalizes high confidence errors. And I think intuitively that makes sense. So if you see somebody in your environment making a lot of correct choices with high confidence, you're probably going to update your weight that you give to that person. However, if you see somebody making very bold claims that turn out to be wrong, you're probably going to actually reduce your weight that you give to that person. And there's also good empirical evidence that this is actually are key features of how we actually track the believability of our social circle. Okay, so now we know what advisor strategies can be. We know what the client's updating rule is. Importantly, every player knows the full rules of the game. So every agent knows everything, and then we can solve this game. And I will show you the solve for one specific situation, but that actually generalized to other situations as well. And I'm going to show you how to solve this if the weight of the advisor 1 is 0.8, which means the weight advisor 2 is 0.2. And this means that advisor 1 is selected, right? It has the higher weight, and that's being selected is going to be a key feature actually of the story. So now what we can do, we can use the game theory theoretical approach of backward induction to ask, okay, what should an advisor actually do in the last round where it can still actually have an influence on the client? So, of course, what it wants to try to do in that situation, it wants to try to make sure that it's also being chosen in the next round, because that's its ultimate aim. And what we can do is we can basically write out a matrix, or we can basically write out all possible combinations of the two strategies that the two advisors can give. So here you see all the possible 10 strategies of advisor 1, so from range from 0 to 1. And here you see all the 10 strategies of advisor 2, again ranging from 0, meaning full confidence white, to 1, full confidence black. And this is for the scenario in which the black color actually wins. And the numbers that you see are the predicted weights for advisor 1. So given the combination of two strategies and outcome is black, this is the updated weight of advisor 1. And in purple, you will see all the values which are 0.5 or higher, which means if that happens, then also advisor 1 will be selected in the last round, right? So that is really the combination where advisor 1 wants to be. So for example, I mean, here in the diagonal, for example, you see that, of course, in these situations, both advisor 1 and 2 give exactly the same advice. They choose the same strategy, in which case there's status quo and the updated weight actually remains at 0.8. You'll see, probably notice that there's a larger portion of the spectrum here is purple, which of course makes sense because, you know, advisor 1 started with a higher initial weight to start with, right? So therefore, also after the updating, it has a higher, in some scenarios, it has a higher chance actually of keeping that advantage. So we can do exactly the same for if the outcome is white, in which scenario, of course, the whole pattern flips. And this allows us to actually derive the payoffs of advisor 1 and advisor 2 of all the possible scenarios. And of course, what advisor 1 basically wants, it basically, you know, given black or white, ideally it would be selected in both of these scenarios. So here, for example, advisor 1 wants to be in these regions where, you know, for both strategies, you actually see purple arising. And that is depicted here in this payoff matrix for advisor 1, where you see 3 parts, but it's part in the middle with the dark purple ones. These are the regions where no matter what happens, no matter if white or black actually is the correct outcome, it will actually be selected in the last round. So that's really where that advisor 1 wants to be. Then there are 2 other parts, P and Q, P being the likelihood that the outcome is going to be black, and Q the outcome that the likelihood that the outcome of the bet is going to be white. So this is a zero-sum game, meaning that one player's gain is the other player's loss. So the payoff of advisor 2 is basically 1 minus payoff of advisor 0. So that you see here in the other matrix, where it's basically the reversed pattern. Now we can use the strategy of backward. Now we can delete weakly dominated strategies to actually see what the rational strategy would be in the end. So for example, what you see here, for example, is that the strategy for advisor 1 to pick 1, so fully confident black, you see that strategy is actually being dominated by 8/9, because 8/9 is better or at least as good as 1. And the same is true then for 7/9, for 6/9, and we actually only are left with 5/9 here. So deleting the strategies for advisor 1 actually leads us to this reduced matrix, where actually advisor 1 only has 2 strategies remaining, 4/9 and 5/9. And now we can do the same from the perspective of advisor 2. And as you might see in advisor 2, there's a number of combinations where the outcome is 0/0 for advisor 2. And so, of course, these strategies get deleted. So in the end, the reduced matrix we end up with is relatively simple, and that's really only these 2 combinations of strategies, or 4 combinations of 2 strategies, where advisor 1 so that's here on this end, we see that advisor 1 is actually always randomizing with some probability between 4/9 and 5/9. So it's actually giving moderate advice. And advisor 2, so that is on top here on top, we see that advisor 2 is actually randomizing, again with some probability, between 0 and 1. So it's actually making a very extreme advice. And what this basically boils down to, what this exercise shows us, is that given all of these assumptions we make, that in this kind of environment, in the Nash equilibrium, what you actually should do is, if you are selected, so if you actually are already being chosen and you have the higher weight as an advisor, you should actually start recommending very moderate. So you should actually not go extreme. You should always communicate your advice with very low confidence, because you actually want to reduce the likelihood that you actually make a big error, which could cause you a big drop in your weight. Whereas on the other hand, if you are ignored, so if you're standing on the sideline, what you actually should do is you should go as extreme as possible, because knowing that you actually have a very low weight, you actually need to do something extreme to try to get actually out of that situation of not being under consideration. So the same basic rule, actually, also we get this if we look at the penultimate round. So if you look further back, of course, it becomes more complicated, but we get the same basic intuition, and also for different starting weights. So this finding is relatively robust, I would argue. And it's important to notice that actually here, both advisors do not necessarily report the truth, right? So they're actually not necessarily selecting strategies that reflect the evidence itself. So having derived this rational strategy, I want to spend the last part to testing this strategy. So what we did is we ran 7 pre-registered studies to test if humans actually follow such a rational strategy as compared to an honest advisor. So people actually fall for this strategy that I just introduced. And here you see a schematic overview of the experiment. I'll also give you some screenshots to give you the idea of how this looked like. So we played this with human clients. So you have to imagine you are a participant and you get to see 2 advisors. You have to select which advisor to follow. And each of these advisors is programmed as either following this rational strategy or playing honest. So basically honestly communicating exactly the level of evidence that they observe. Then you have to choose an advisor. So let's say in this case, the participant selects advisor 2. You then get to see the advice that both advisors give to you. And in this case, you select advisor 2 and you see advisor 2 advised you that, okay, I think it's going to be right and I'm somewhat confident. So 2 out of 5 stars. So the stars here indicate the confidence level, but you all see that advisor 1 actually, he actually advised the opposite. So you follow the advice of the advisor that you selected. So that means you're actually betting on white. And then in the last instance, there's an outcome. So there's an outcome drawn from the evidence, and in this case, you won. Now we started this with single clients. So these were human participants making for 20 consecutive rounds a choice which of the 2 advisors to follow. And we ran 4 different studies with single participants. I won't go into details of all the studies, but for each of these panels, on the x-axis, you see the round, so round 1 to 20. And on the y-axis, you see the likelihood that this rational strategy or rational advisor was selected. By chance, you expect a 0.5 here if there's no difference between honest and the rational advisor. You see that in almost all situations, we find pretty good evidence that the rational strategy actually trumps the honest strategy. We played this also with different uncertainty levels, and the red was the highest uncertainty level, and that actually was the best for the rational strategy, with uncertainty being actually how easy it was to predict the trial outcome. Then we moved on to looking what would happen in majority voting groups. Of course, in elections, that's very often procedures like this are used, where many people are consulted independently and these votes are being aggregated. So in these experiments, what we did is we had groups of 5 individuals playing this together, but making independent choices, meaning they all independently decided which advisor to follow. And then these independent decisions were aggregated via a majority rule, meaning that if for example, 3 out of 5 would select advisor 1, the whole group would actually select advisor 1. So this is really an election-like procedure. And results here of 2 different experiments, one online, one in the lab, are shown here. with the green line being the independent decisions of the 5-person groups. And you see that already these independent decisions are again above or in favoring the rational strategy. And the dark blue line here is actually the majority vote itself. The majority vote itself was actually much more likely than the independent decisions to fall for that rational strategy. The red line is again an individual control condition. Then finally, we had a look at communicating dyads. So what we had here, we had people come into the lab in 2-person groups, and these people played exactly the same game, but they actually first discussed with each other which advisor to select, seek consensus, and then decide which advisor to follow. Doing this, we again found relatively good evidence that also for dyads, which here is the pink or purple line, that also for dyads, it was more likely that this rational strategy actually drew the attention. It was more often selected by the dyads. Again, the red is an individual control condition. Yeah, so one question one may ask here, or that we at least ask ourselves, is, okay, how does this rational advisor actually gain social influence? What's the mechanism? Or another way of asking that same question is, what are the cues that participants use to actually change advisor? And the answer to this you see in these graphs here for 3 different conditions. So a human client was more likely to change advisors if, first of all, if they lost, which of course makes perfect sense. So if you lose a bet, of course you're probably inclined to actually seek different advice. But losing in itself was not the only thing that mattered. So it's not only win, stay, lose, shift. What also mattered actually is the red coloration here, is that this other advisor that you did not select, so the ignored one, that this one actually gave opposing advice from the advisor that you were following on that trial. So basically, if you lose and you see actually another advisor making a very different prediction, that really draws in your attention. And that is exactly, of course, what this rational strategy is doing, right? It's really trying to make itself distinct from an honest one when ignored, not when not ignored. That's the fascinating thing, I think. Once it's selected, it actually beautifully aligns and will actually go in favor of evidence. We can talk more about that later. So to sum up this work, so under these 3 conditions of information asymmetry, delegation of decisions, and future uncertainty, we see that there's one rational strategy emerging in the game that I've shown you, namely that if you as an advisor are selected, you actually should advise moderately. However, if you're ignored, you actually should go extreme. You should actually go full out on what you, even if the evidence is not portraying this. In the experiments, I hope to have shown you that this rational strategy can actually sway individuals, majority voting groups, and also consensus-seeking dyads. And so we believe that this actually of course, it does not explain misinformation and all. There's much more to say to this, and that's not what I claim. But I think it can help explain, at least to some extent, why you very often see that politicians, especially underdog politicians or who are new on the scene, that they will take relatively extreme or opposite positions from the ruling parties, really exactly to kind of make yourself distinct, to provide a different narrative, even if the evidence actually does not give you a lot of confidence that such a narrative would actually pan out. Another aspect, I think, where you can see this, for example, is if you see firms that make very good offers, if you know that you're actually if you actually are a member of a different firm, then they will really give you a very different perspective on what they have to offer you, as compared to when they actually know that you're, for example, really looking at the market and really playing the field. And you may also think of some other examples yourself where you actually might find some evidence for this strategy to actually, to gain social influence, so to speak. Okay, so that was what I wanted to share here with you in this talk. Thank you very much for all of your attention. I think, again, all my collaborators, and I'm presenting this work, but this was truly a big collaborative effort from these people you see listed here. So thank you.
Thank you so much, Ralf, and thank you to all of the faces up there. I know 3 out of the 5, and I've individually seen parts of this work, so it was wonderful to see where this project has led to. And I was very impressive to see the 3 experiments side by side. I do have some clarification questions, if I might, while we wait for YouTube to catch up with us. So one of my questions was, did in the group scenario, so without, I assume, so they discuss, they don't discuss, in the group one, they don't discuss, they all just individually vote, and then you create an average of the group. Do they get any feedback, or do they just see what the average was, and then they can calculate the difference between my individual vote and the average vote?
Yeah, that's a good question. We also we were uncertain how to set it up in the end, because you can, of course, on the one hand say, okay, you give full disclosure, so you see how all of the 5 members are voting, and you could maybe even track the reputation of each of these 5 individuals to really form beliefs about what they all might expect or what they believe. What we did is we actually made it as kind of like anonymous as possible, and also with very low information quality. You only saw what the group favored as a majority vote. So you only received, okay, advisor 1 was selected by your group, and you didn't see which individual decided for what. I mean, the feedback you got was, of course, whether the bet that you were following was actually correct or incorrect. So of course that gives you some way of knowing, of course, the quality of advice, but you did not see how each single group member in the group of 5 voted on which advisor to follow. Does that answer your question?
Yeah, that's exactly clear. So basically, they just calculated if they want to know whether they are voting with everybody, if they're on the right track. Because assumedly that's what you do, right? And that's why we always compare and we go, oh, am I voting for the right person? So all they can do really is compare their individual vote to the average.
Yeah, I mean, I think it's fascinating to run like a similar study where you actually see the opinions of others directly. So you actually see how each individual is voting, and then see if kind of like trying to achieve alignment with others may actually kind of like alter the benefit of the rational strategy. I think that's a very interesting question to ask. We didn't do it. We thought, let's keep it as simple as possible, because it was already like a kind of a complex design experiment with 5 people online. Yeah. So we thought, okay, let's not bombard them with more info.
No, it's perfectly normal and correct. I do have another clarification question, because I do find this so interesting. Did the dyad make a joint decision again, or did they just, or do you do an average? Which is it more like the group scenario, or is it that they actually come up with a decision together and then?
So they were really, they only had one keyboard in front of them. So they only had one keystroke to make. And we stimulated them or asked them to always, after each decision, to kind of like give the keyboard to the other person. But we asked them to always discuss first. So they really had to see consensus and trying to at least make sure that they equally contributed to the key pressing. We hoped at least to kind of like avoid that there's one person just always pressing the key and actually neglecting the communication itself. Yeah, so that's the implementation that we chose.
Yeah, and I mean, perfect. Yeah, I think what's nice about the 3 studies side by side is I mean, combined, you basically do get a sense, because it's just so consistent, that you do get a sense that this is just a general mechanism of how we get people to listen to us. So it was irrespective of the context, which I find quite. I was impressed that it's so consistent, that we are just so stupid as beasts. That we want to get people's attention, get that salience network going. Go extreme.
Yeah, I mean, I think maybe one thing to hear. I think that if we for example tried also extreme. We also, if you play too much, if the rational strategy becomes too extreme. I mean, I would need to go into more detail then, but there is also a limit to this rational strategy. If you actually go too extreme, and for example, if the evidence in the environment is very high, but you consistently actually make extreme predictions against the evidence, at some point you will actually, an honest advisor will actually take over. So there are some areas here that I didn't have time to go into, where you'll see, okay, there's a limit to what overconfidence or going against the actual evidence can do in these situations. Yeah.
Well, I mean, obviously the natural next question will be what happens when you don't have this asymmetry. So you had your 3 preconditions, but it'd be interesting when that asymmetry is not there, because assumedly voters do actually have a sense of what's going on around them. Maybe not always, but it would be nice to invite you back when you have maybe data on that, because that would be the best.
Yeah, I fully agree. I think kind of varying all these levels of these 3 key characteristics I introduced, I think that's a really nice step forward, and actually also can also maybe give us some indication of what kind of tools we could actually give to people to actually inoculate or harness them against such strategies. Where, for example, getting personal evidence yourself is of course one very prominent one.
Fantastic. Well, I want to thank you again so much for your time. We've heard about updating in voters. We've had updating in autistic individuals. And we now just have to say thank you for your time, your presentation, Ralf. And we get